I know that we've already talked about the solar system in some terms. We're going to dive into some of the details of the solar system and look at some of the individual planets and characteristics of those. So what do we know about our solar system already, or what have we've done already? We've already talked about the distances. The distances in space are big, really big. So big that the things that we use, or the ways that we measure distance on Earth, don't really work when we're talking about space, because there's just too many of those kilometers. So we end up using new units. So one of the things that we've used is the astronomical units, and that's pretty much what you're going to see today as we talk about these things. We're not really going to worry about the kilometers. It's going to be astronomical units. We can also talk about light years. Now, we're not going to talk about light years today because we're dealing with the solar system. Light years are really large, and we don't need them to talk about the solar system, excuse me. Okay, so what are we going to talk about? Well, once we get talking about the planets themselves, we're going to talk about the distance, how far away they are from the sun. We're going to talk about the rotation. So as it spins around on its axis, we call that 1 day. What would a day look like on Mercury? How long is it compared to us? Revolution is how long it takes to go around the sun, or what is 1 year for that planet, and the diameter. Now, the diameter as a number, actually most of these things as numbers, you're not really going to need to know the actual number. It's just for a comparison, but for diameter, I do want you to at some point be able to compare the planets for size, which one is the largest, smallest, and rank them in between, just for something to do. So the diameter, that would be taking a look at the planet as a circle and how far across that circle would be. I know you know what diameter is. This sheet is part of the package that went out. I'm going to recommend that you have it, and then at certain points pause the video so you can write down some notes. Not everything has to be written down word for word as what you see up on the screen, but a bunch of the stuff should be there. So you should know some information about each planet, how they're similar, how they're different, a unique feature of each planet, and of course the distance, rotation, and revolution. Okay, some basic stuff about our solar system. There's 4 inner planets, and those have a rocky, solid surface. Then there are 4 outer planets, and those are all what's called gas giants. They're not solids. They're not made of rocks and stuff. And then there's a bunch of other stuff in our solar system that we're not going to worry too much about today. But there are other planets. Some of the planets have moons. We got one. Some of the planets have more than one moon. And there are going to be other bits and pieces that we'll maybe talk about, maybe won't. And then if you're looking for a way to keep track of those planets in order, because I do want you to be able to do that, this little memory trick might help you with that, where the first letter of each word represents the letter of the planet. Okay, let's start with the planet closest to the sun, and that is Mercury. And Mercury has no atmosphere, so you wouldn't be able to breathe anything on Mercury. Its surface therefore also is very cratered and so on, much like the moon, partly because there's no atmosphere to protect it. So our atmosphere protects us from space stuff. Temperatures really range a lot from 400 degrees Celsius on the sunny side to minus 180 degrees Celsius on the dark side. So if Darth Vader asks you to go to the dark side, you're going to want mittens. Definitely mittens. Now, if you were living on Mercury and you wouldn't be able to breathe, but okay, let's just say distance from the sun is 0.39, so it's pretty close to the sun. Rotation is 60 days, so from sunrise to sunrise, that is roughly 2 months. It moves kind of slowly. Days are long on Mercury. The year is really short, so to get all the way around the sun, it only takes 0.2 years. To put that in perspective, while Earth, going from one birthday to the next birthday, takes 1 year, on that same amount of time on Mercury, you would have 5 birthdays. That means I would be like 250 years old, and I would look exactly like this. I need to go sit down now. Moving on. On Venus. Venus has a similar size and so on to Earth. It's also roughly the same gravity and so on, same mass. It has a lot of greenhouse gases though, so it's really not habitable at all. So it's even hotter than Mercury, even though it's farther away. So the atmosphere there is trapping more heat. It also rains sulfuric acid, which would really make a mess of your hair. But you'd never see it because it'd burn out your eyes too. In terms of the rotation, revolution, diameter, those are the numbers. I'm not going to say too much about them, other than rotation is really, really slow again. So from sunrise to sunrise, 240 days, that is about 8 months, give or take. Long time, right? Sunrise to sunrise. So you'd be, never. Earth, well, what are you going to say about Earth that you don't already know? But one of the cool things about Earth is it is perfectly situated and perfectly provided for supporting life. You can find water in all its forms on Earth. It's the only planet that can support life with that atmosphere because we need to breathe. And we have the atmosphere which protects us from all kinds of things. It protects us from asteroids or meteors. It also protects us from radiation, certain types of radiation. Water covers so much of it, which helps regulate the temperature a lot as well. Active volcanoes, because sure, why not? They're fun. And I'm not going to tell you the distance of revolution and the rotation times of the Earth because you already know those. I will give you the diameter number just for reference. Mars, which is sort of the planet that we're looking to say, hey, let's go live there. Maybe. It's called the red planet. It's called the red planet, even though it's kind of orange, but we'll cut them some slack because it's had that name for a long time. Maybe they weren't very good at colors. Don't know. It has a lot of iron there, so maybe we could do some, anyway. I was going to say we could do some mining up there, but when we start living there, we could all be iron miners. It has polar ice caps, so it does have water on it, just at the poles, not where people want to live. Temperatures are around 16 degrees Celsius, which seems workable, habitable. We can maybe work with that. But it has 2 small moons, so a couple of moons. Cool. In terms of distance, rotation, and revolution, you'll notice they're kind of similar to Earth. A little bit longer in a day, a little bit longer in a year, but not crazy different from what we're used to. Once you get past Mars, the next thing is the asteroid belt. The asteroid belt is a bunch of big rocks flying around. If you think about the rings around Saturn, if Saturn was like the sun, then the asteroid belt would be the rings. Except on this, we've got planets inside there, so well, maybe that's not the greatest example. But beyond that, there's what's called the snow line and so on. Oh yeah, snow line, there you go. And that, on the inside, it can be warm enough from the sun that the water can melt and be a gas. It can be a liquid. Beyond that, any water that exists would never be a liquid or a gas. It would only ever be a solid. Okay, Jupiter. Jupiter is the biggest planet. And I'll show you how big in a minute. But as a rough comparison, picture the Earth times 320, because you probably can't do that. I know I can't. It has a lot of moons, 64 of them in the last count. And there's 4 that we can see if you've got a decent telescope from Earth. You can see these moons. The funny thing about Jupiter, and this is true of all the gas giants, is it's not a solid. It's not made of rocks. It's not made of it's made of hydrogen and helium gas. And I want you to kind of remember that when we come back to talk about something else later and we'll refer to it, because the fact that it's made of hydrogen and helium gas actually is going to be similar to something else that's big and important in the solar system. Anytime you see a picture of Jupiter, there's almost always this big red spot on it, and that's a storm. And that storm has been going on for like 300-400 years that they've known about. It's a raging storm. Temperatures are kind of cold, but not as cold as you might think. The distance, rotation, and the revolution, so it takes 12 years to go around the sun, and it's that big around. So when you compare it to the size of the Earth. And then you move out to Saturn. And Saturn, second largest, it has a lot of rings. And the rings end up looking, instead of like little rings, end up looking like bands, which you see in this picture. Dust, ice, rocks. It's got a lot of moons as well. You can't really see any of them from Earth without a really, really good telescope. Largest of those moons is Titan. And it also is made of hydrogen and helium, like Jupiter, and kind of like the other gas giants. They're big, they're made of gas. Temperatures are really, really cold. And then you got the distance, rotation, revolution, and the diameter. So revolution trip around the sun is 30 years, but the rotation is about half a day. So from our sunrise to sunset, or our sunrise to sunrise, one day, you'd have that a little more than twice on Saturn. So that's a moving pretty quick planet. Then we fly out to Uranus. Uranus is, it's one of the weird, it has a weird feature that it does not spin on its axis like this, as if it's standing up and spinning. It's more like it's laying down, or it's somersaulting. It rolls around compared to all the other planets. It has a blue color, and the blue color is caused by methane in the atmosphere. It also, though, is made mostly of hydrogen and helium, but methane in the atmosphere. It has rings, although they're very, very faint and difficult to see, and it has some moons. Temperatures get really cold again, and then what you have is a distance, rotation, revolution, and diameter. Now, the revolution is kind of interesting, 84 years. That means you would have one birthday. So hopefully you did better than just socks. Neptune is the last planet in our solar system. It's the farthest one away. It is similar to Uranus in the sense that it looks blue because it has methane in the atmosphere. It's mostly made of hydrogen and helium. It does not roll. It spins like all the other planets. So in terms of a unique feature, Uranus is the only one that rolls. Sometimes they'll say that it tumbles. It doesn't get much of its warmth from, not that it has any warmth, but it doesn't get a whole lot of energy from the sun in terms of heat energy. So any temperature numbers are going to be mostly produced by the planet itself, and we'll talk a little bit about how that happens. But the planet itself generates some of its heat energy. Not very much, because it's really, really cold. Distance, rotation, revolution, 165 years, you would never get a birthday, except for your your actual birthday, I guess. But you'd see a lot of days, because in the time it takes, well, if our day is 24 hours, this day is 16 hours, give or take. Okay, what do we need to know? What do we need to say? That was interesting. Well, I want you to know common features of the inner rocky planets, common features of the outer gas planets. I want you to know something unique about each one of those planets. I want you to be able to list them in order of distance from the sun, and some of the planets by size. Now, I'm not going to say, well, how big is which one is bigger, Uranus or Neptune, but things like Jupiter being the largest, Saturn being the second largest, Mercury being the smallest, things like that I think are worthwhile. Anyway, we will talk to you another time.